Hello, everybody. Today we're going to tackle Eureka Math / Engage New York Module 1, Lesson 3. We're going to be talking about equivalent ratios. Now, hopefully you've talked about equivalency in the past. Probably where you're most familiar would be equivalent fractions. If you have 1/2, and then you said, well, okay, let's take what I like to affectionately call the magic number, and let's say we use 2. 1 times 2 gives us 2. 2 times 2 gives us 4. We have 1/2 and 2/4 being equivalent, right? If you take that, shape, you can use any shape. We'll use a circle. We have 1 out of 2 pieces shaded in. Well, we cut that into 4 pieces. Now we have 1, 2 out of 4 pieces shaded in. So 1/2 and 2/4 are equivalent. Equivalent ratios work in similar ways, much the same way. And we're going to look at a few different ways to get equivalent ratios and how you might be able to use tape diagrams to answer some of the questions that you'll see and what equivalent ratios really mean. All right, let's tackle our first question. And this question, like all the questions in the video, come from Eureka Math, so credit to them. Let's jump right into it. If Shani and Mel are working on an art project together, and Shani brings 7 inches of ribbon and Mel brings 3 inches, what would that ratio look like in a table? Oh, okay, let's jump right into it, right? We'll put Shani's name down. We'll create our table here. And on the other side, we'll put Mel. Well, if Shani brings 7 inches of ribbon and Mel brings 3 inches of ribbon, your table shows us that the ratio of ribbon that Shani brings to the ratio of ribbon that Mel brings is 7:3. And so let's say they stuck with that ratio and they decided, you know what, we actually need to double the amount of ribbon we need. We need to double this art project in size, but we're going to bring the same ratio that we had already decided to bring. Well, Shani, if you're going to double that, we need to multiply that by 2, right? So 7 inches times 2, instead of 7, this time she's going to bring 14 inches, right? Well, Mel would have to multiply by the same amount, 3 times 2. He's going to bring 6 inches of ribbon. So their new equivalent fraction, or excuse me, your new equivalent ratio would be Shani brings 14 inches to Mel's 6 inches. And 7:3 and 14:6, those ratios are equivalent to one another. Let's say they're working on the project and they say, you know, we actually need 3 times what we originally thought. So 7 times 3 is going to give us 21. 3 times 3 is going to give us 9. And yet again, we have another ratio, 21 to 9. Let's look at that another way. Our original ratio was 7:3. When we doubled that, we kind of used what I like to, again, affectionately refer to as that magic number. We said, okay, times 2. 7 times 2 is 14. 3 times 2 is 6. We're still equivalent. If we take that original ratio and we said, okay, we're going to use that magic number this time of times 3. 7 times 3 is 21. 3 times 3 is 9. 21 to 9 is an equivalent ratio of 14 to 6 and 7 to 3. And we could keep going with that. Okay, we're going to look at another question. And this time, again, it's from Eureka Math. This time I want to look at how we would use a tape diagram to work this question out. So the question reads as follows. Mason and Laney ran laps to train for their long-distance running team. The ratio of the number of laps Mason ran to the laps Laney ran was 2 to 3. And you see that they've written it out in word form. That means the same thing as 2 to 3. They're both ratios, just 2 different ways of writing it. So, if we're looking at number of laps Mason ran to the number of laps that Laney ran, right, we're going to put them in that order. So for our tape diagram, Mason ran 2 laps. So I'm going to create my tape diagram this way. The reason I cut it into 2 sections is because he ran 2 laps, right, for every 3 that Laney ran. And so if we created 2 sections of our tape diagram for Mason, we have to create the same, that's not going to quite work. We have to create the same as much as our artwork allows us for Laney, except he didn't just run 2. I only drew 2 so you can see that those are basically the same size, right? So now I'm going to add on a third. So Mason ran 2 laps, Laney ran 3 laps. Or that at least is the ratio. Here's the thing. We don't actually know that Mason only ran 2 laps. If you're training, or that Laney ran 3 laps for that matter. If you're training for a long distance run, chances are you're not just running 2 laps. You're probably running farther than that. So let's say that Mason actually ran 4 miles. This is the part where it can get a little tricky. Our tape diagram, we want it to be the ratio. So it says 2 to 3, so no matter how far he actually ran, we're going to go with 2 to 3. That's why there's 2 sections in Mason's tape diagram, 3 sections in Laney's tape diagram. But we know that Mason's tape diagram is actually 4 miles, right? So if you take that 4 miles and you divide it into each of these 2 sections, you're basically doing 4 divided by 2. So we know that each section of the tape diagram represents 2 miles. Down here, we can look at Laney, and since his tape diagram sections are the same size as Mason's, we know that actually each of his sections are also 2 miles. So if we know that Mason ran 4 miles, and the question is how far did Laney ran? Well, or how far did he run? We can say 2, 4, 6, and we know that in this case, Laney ran 6 miles. If, for instance, we wanted to change that, and we said, I'm going to erase all this, get this all out of here. We're going to change the problem a little bit. Ratio stays the same. It's still 2 to 3. So you notice, fix that a little bit, you notice that I'm still leaving my tape diagrams as 2 for Mason and 1, 2, 3 for Laney. But let's say that in actuality, let's say that Laney ran 900 meters. We're totally changing it up. We're not doing miles, we're doing meters now. Say you ran 900 meters. Well, I've got to take that 900 meters and divide it into 3 sections. Well, 900 divided by 3 is going to give us 300. So I'm going to put 300 in each. You can double check it. 300, 600, 900. All right, we're good to go. So how far did Mason run? Well, Mason ran a 2 to 3 ratio. Laney ran 900 meters. I know each section of my tape diagram is 300, so I can fill in the same thing for Mason. 300 and 300 would give us 600 meters. So again, when you create that tape diagram, whatever your ratio is, that's the number of sections of your diagram. Mason ran 2, Laney ran 3, so that's why Mason has 1, 2 sections of his tape diagram. Laney has 3 sections. And the sections are equal in length, at least as equal as I can make them with my drawing. But you see, I basically line them up, so it's really easy to look at it, and you can see visually that they match. Okay, last problem, and then we'll have a chance to talk about this in class. Josie took a vocabulary quiz. The ratio of problems she got incorrect to the number of problems she got correct is 2 to 9. They're giving you the ratio. So I can look at it and say, okay, oops, incorrect, correct, incorrect to correct. We have 2 to 9. Not a bad ratio. Now, if I asked you, okay, how many problems were on that quiz, you might say, well, there's 11, right? Because she missed 2 problems and she got 9 correct. And if only that were true. But here's the thing. It could be 11 or it could be a different number. We don't know unless someone actually tells us the number of incorrect or the number she got correct, and then we can use a tape diagram to actually go from there and figure it out, which is exactly what we're going to do. So it says the number she got incorrect to the number she got correct. So I'm going to put them in that order. Incorrect, correct. Well, I'm going to also use, just like we talked about a moment ago, a tape diagram. So I'm going to split the incorrect diagram into 2 because it's a 2 to 9 ratio. So how many would I split the correct diagram into? You got it, 9. Okay, so we have 1, 2 for the incorrect portion. 1, 2, 3, 4, 5, 6, 7, 8, 9, because we have a 2 to 9 ratio for the correct portion. Now, if they told us that Josie got 8 questions incorrect, I can then work with that. I can say, okay, I know what we're doing now. This incorrect section equals 8. Well, it's 8 divided into 2 parts. 8 divided by 2. I know that each of these boxes gives us 4 questions, right? Well, down here, I know there are 9 boxes, and if they're each 4, yeah, I could draw 4 into each one of them and add them all up, and that would get me my answer. Or I could just say, I know that's 4 in each box. I know there's 9 boxes. That's going to give me 4 9 times. So I would do 9 times 4, which means that she got 8 incorrect. She got 36 correct. If I asked you how many problems there were total, well, she got 36 correct and 8 incorrect. Add those two together. That means there were 44 total problems. Okay, let's scratch that. Let's say that this was a huge test. I don't know why it'd be this big, but let's just say that Josie actually missed 20 questions. Do I need to change my tape diagram? No, I don't. It's still a 2 to 9 ratio. 2 incorrect, 9 correct. So for my incorrect, I've got my tape diagram split into 2. For the correct, I've got it split into 9. And please don't get frustrated drawing the tape diagrams. Take your time. Erase if you have to. I've already had to pause. You didn't see this, but I paused the video and I had to redraw my tape diagrams because it's kind of hard to draw and keep it accurate. It's important that they're lined up and accurate. If you have grid paper, even better. Okay, so let's say now, I'll change colors here. Let's say that Josie missed 20 questions. Well, 20 divided into those 2 boxes, I know that's 20 divided by 2 is going to give me 10 in each box. Well, if each box is 10, then I come down here and I know each of these boxes is then 10. And it's just a matter of adding a whole bunch of 10s, or you know, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 10s. 9 times 10 is 90. She got 90 correct. She got 20 incorrect. And if you wanted to know how many total questions there are, well, it'd be all the questions. It would be all the questions she got right and all the questions she got wrong. 90 plus 20, 110 total questions. Okay, I hope that has cleared up a little bit about equivalent fractions. We're going to work with that and continue working with equivalent fractions. And I can't wait to discuss this with you in class. Thanks for watching.